Greetings and welcome, friends. We're taking a look at last night's quest, page 489, Su tarea de anoche, 21. Here I've got 6x cubed plus 9x squared minus 6x plus 2. I'm dividing by x plus 2, and they said, divide using synthetic division and write your answer in the form dividend equals quotient times divisor plus remainder. So let's do that. So in the box, I throw a little -2 there. And it doesn't look like I need any placeholders, so I'll put a 6, nueve, -7, positive doso. There we go.
You're disgusting.
Okay. So let's divide this. Add, multiply. Add, multiply. Add, multiply. Air.
Isn't your supposed to be positive because you were using synthetic division?
Well, for plain old synthetic division, it's the opposite. And I'm glad you pointed that out. For synthetic substitution, it will be the same. So, very good distinction. Same question last class. Yeah. So what is my quotient? I guess I'll write it in this, I'll call it Q of x if I wanted to. The quotient would have been from this guy. Well, I guess more specifically from those three. What's the quotient going to be?
Quotient 6x squared.
Yep, minus 3x plus 0 or whatever. Just ignore the plus 0. And the remainder is the 2. So they said to write it in the form dividend. So that was this part, the 6x cubed plus 9x squared minus 6x plus 2. Theoretically is equal to the quotient, this guy, 6x squared minus 3x, times the divisor, which was x plus 2, plus the remainder, which is this guy right there, the 2.
How do you determine whether it's something x squared as a quotient?
So that question is where this came from?
Yeah.
Well, I realized that we were dividing a cubic by a linear, and in general, x cubed divided by x to the first is, the first term had to be an x squared. So that's how I figured that out. You also can count backwards, where this is the remainder, and then this would be your constant, and then this would be your linear term, right? Linear as an x to the first, and then this would be your quadratic term. So.
Why isn't the remainder in the
I've got the remainder hanging out here. I don't believe I'll need it. And to verify, so let's see, dividend equals quotient times divisor plus remainder is the form that I just wrote this in. Remainder. Here we go. So that would be the answer that they kind of wanted it presented as. And I don't think that's actually that interesting to write the answer that way. It's going to relate to what we're doing today. But let's actually just verify that real quick before we move on. If I was to FOIL out the right-hand side, I would have 6x cubed plus 12x squared. And then let's see, this guy and this guy. That would be minus 3x squared minus 6x plus 2 still hanging out. Good old buddy doso. So that would 6x cubed. There we go. There's a better 3. I could combine these like terms. Right? And that would be plus 9x squared minus 6x plus 2. And behold, I think I saw that before. What? Represent. That means we did it right. So that's good stuff. Good stuff. So I just want to point out that there's validity to writing the answer this way. So they asked another question. They said, is the binomial a factor of the polynomial? And I haven't told you how to do that yet, but you might have been able to figure it out. So question, is x plus 2 a factor of this? Why would you say no? Because there's a remainder. If it was a factor, friends, Zach friend, right? So yeah, if it was a factor, that means it would have divided in evenly, and that would have been a 0. So good call. So that's what the book was referring to there. We're going to talk about that a little bit more later on today, friends. Here we go. So let's look at the next problem. So Zach, use synthetic substitution to find f of 2 and f of negative 1 for each function.
Replace every x with 2. And then
That would be direct substitution. Direct substitution. Because they're going to be equivalent. So synthetic substitution, I would do 2 goes into 1, negative 8, negative 2, and 5. Whoop, 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 whoop.
So you just take the x and do it?
Yeah, I just take the 2, and it goes right here.
Well, I didn't do that way.
Well, then make sure you know how to, because you would have gotten it wrong on the short answer part of a quiz, because you wouldn't have been able to, because I want you to know both ways.
Well, if you were able to do the previous problem, you could do this one.
Well, 2 times negative 6 is negative 12. Let's see, add them up. That's going to be negative 14, and multiply that. That's negative 28, and that's negative 23. So the remainder being negative 23 tells me that f of 2 is equal to negative 23. And that's what you guys should have gotten as well, right, if you did direct substitution?
Yeah.
Yeah. So make sure you understand the difference between synthetic and direct substitution. Let's do f of negative 1 real quick. So that means I would synthetically divide by negative 1. So I'd have 1, negative 8, negative 2, and 5.
Wait, why did you do the opposite of the first, or the same as the first one? Wait.
All right, back on the first problem, I was regular doing synthetic division, and in that case it's the opposite. And I'm glad we're pointing this out. So it's the opposite for this. And I'm going to keep explaining it just for our internet friends, because I'm sure some of them have that same question. And it's the same for this.
I thought I said negative 2 in the
I got you. Well, nonetheless, I'm glad I got to explain it again. I'm glad. Let's see. So let's synthetically divide. So let's see. Add them up. 1 plus nothing is 1. Then multiply negative 9. Multiply positive 9. That's 7. Multiply negative 7. Add them. Negative 2. So my remainder is negative 2, meaning that f of negative 1 is negative 2. Behold, friends. Wonderful stuff. So that's the idea behind synthetic substitution. You can use it to kind of quickly evaluate a function at a given value. Today we're going to talk more about what happens when you get a 0 for your remainder. It's going to be interesting. It's called foreshadowing. Like now this is when I'd cut to commercial and then like there'd be some dramatic music. Yeah. Yeah. You got to wait for the sequel. Bam. There you go. So anyways, have a great day, friends. Bye-bye.